All right, in a previous problem, we were given a bunch of probabilities that a certain firm will get awarded certain projects. And we're supposed to now find some conditional probabilities as well as interpret them in the context of the problem. So let's start with part A, the probability of A2 given A1. And for this, we're going to use our definition of conditional probability. So that's going to be probability of A2 intersect A1 all over the probability of A1. We're given both of these values. The probability of A2 intersect A1 is 0.11. The probability of A1 is 0.22. This reduces down to a half, or 0.5. And what this means in the context of the problem is that there is a 50% chance that given the firm is awarded project number 1, it will also be awarded project number 2. All right, next problem. We have the probability of A2 intersect A3 given A1. Once again, we're going to use our definition of conditional probability. So A2 intersect A3 intersect A1 all over the probability of A1. All right, since intersection is both commutative and associative, this is the same thing as the probability of A1 intersect A2 intersect A3, which turns out to be 0.01 over 0.22 for our probability of A1, and this is 0.0455. Now, what this means is that given that the firm is awarded project number 1, there is a 4.55% chance that the same firm will be awarded both projects 2 and 3. Remember that intersection generally means and when we're interpreting a problem like this. Now we have probability of A2 union A3 given A1. Once again, we're going to use our definition of conditional probability. All right. Now if we look at this top and we see, intersection distributes, so we can expand that out. Union A3, A1. There we go. All right. Now we can use our addition rule for probability to expand the numerator to probability of A2 intersect A1 plus probability of A3 intersect A1 minus probability of, well, it'd be the intersection of both of these, but that's just A1 intersect A2 intersect A3 because the A1 is redundant all over the probability of A1. So that's going to be 0.11 plus 0.05 minus 0.01 all over 0.22, just substituting in. And that ends up being 0.682. In the context of this problem, what this means is that given that the firm is awarded project number 1, there is a 68.2% chance that it'll either be awarded project 1 or project number 3. Project number 2 or project number 3. Keep in mind, a union generally means or. All right, finally, we have this mess. The probability of A1 intersect A2 intersect A3 given A1 union A2 union A3. Once again, using our definition of conditional probability. Let's see, A1 intersect A2 intersect A3 intersect A1 union A2 union A3 all over probability of A1 union A2 union A3. Now, in order to simplify this top, I'm going to use a Venn diagram as a visual. So let's call A1 the green, A1 the red, A2 the green, and A3 the blue. And if we make a Venn diagram, like so, where these colors correspond to each of these A's, then we know that A1 intersect A2 intersect A3 is the center section here, and that A1 union A2 union A3 is the entirety of what's inside these circles. Now, in order to find the intersection, we need to figure out what's common between the two. Well, that's just A1 intersect A2 intersect A3. So this top is just the probability of A1 intersect A2 intersect A3. Now we have to use our addition rule for 3 variables on the bottom here, which is probability of A1 plus the probability of A2 plus the probability of A3 minus the probability of A1 intersect A2 minus the probability of A1 intersect A3 minus the probability of A2 intersect A3 plus the probability of A1 intersect A2 intersect A3. By the way, yes, I am aware this was a required part of the problem where these probabilities come from, but that's just to jog your memory in case you don't remember that we did that earlier, or if you just wanted to compute it by hand again. All right, this top part is 0.01, and this bottom part ends up being 0.22 plus 0.25 plus 0.28 minus 0.11 minus 0.05 minus 0.7. That doesn't look right. It should be 0.7, shouldn't it? All right, yeah, that should be 0.7. My fault. Just looking back at the problem, I just realized that it looked way too big. Plus the probability of 0.01, that ends up being 0.53. If you divide that out, that becomes 0.0189. Now, what does this mean in the context of the problem? Well, that means that given that this firm got awarded either projects 1, 2, or 3, that there is a 1.89% chance that it got awarded all 3 projects, projects 1 and 2 and 3. And there you have it.